Good morning to the people. Welcome to Yebo Tutor Livestream Help on this beautiful Sunday. The weather is quite cold and calm, but yeah, here we are. Let's do some calculus and solve the paper for this year. And hopefully, you guys will enjoy. And please don't feel scared to ask questions. Ask us any question on the comment section or type in the WhatsApp group. We'll be there to assist you and respond in real time. Wake up your friend, wake up your housemate, your hostel mate, and tell them that it's about to go down. So let's just look at this question. It's only going to be only question 9. We are looking at optimization, which is quite tricky. Now we sort of like the application of calculus. Of course, by now everyone knows how to do and calculate the first principles, the f prime from first principles to calculate using the power rule. Of course, let's just do a small quick recap whilst people are coming in. So of course we know that f prime of x is the same as the limit as h approach 0 of f of x plus h minus f of x all divided by h. Of course, this is when they ask us to solve from first principles. Then now we have what we call the power rule, where now we just derive things fast. So for instance, e.g., we are given f of x to be equal to x to the power 10, then f prime of x will be equal to 10 times 1, that's 10, then 10 minus 1, it's 9. So this is the power rule, and we applied the power rule in order for us to solve fast, because when we are solving using the first principles, it takes a lot of time. But when we are solving using what do we call this, when we are solving using this straightforward power rule, it makes everything short. Okay, now let's get down to the business of the day, which is question number 9, calculating the volume. So as we can see now, Let's do this. Yes, a cone with radius r centimeters and height ab is inscribed in a sphere with center O and a radius of 8 centimeters. OB is x. Okay, we can say that. We can say that that's a cone, that's a sphere, that's a triangle also there. We can see the radius r, we can see all the values. Of course, from grade 11, we have been taught how to calculate the volume of a sphere. We know how to calculate the volume of a cone. So yeah, we're just happy, guys. Oh, if it's your first time, don't forget to subscribe, to comment, to like, and share with friends. And don't forget to join our WhatsApp group and the description of this video. Join so that you can have access to the past papers, access to ask question anytime, even at 12 o'clock at night. You ask, we still respond to your question. Now, calculate the volume of the sphere. Of course, we know that the volume of the sphere is 4 over 3 pi. Okay, cube. They've already given. This question is so nice, guys. 9.1. The volume of the sphere is always equal to 4 over 3 pi r cubed. They've already given us the formula. Do you see the beauty of that? So we just write 4 over pi r cubed. Then what is our r? That's where it's important. Of course, our r is going to be equal to 8. So it's going to be 4 over 3 pi times 8 cubed. Then we use our Casio calculator. Here it is. Let's go. 4 over 3 times pi times 8 cubed. Then I'm getting 2048 divided by 3 pi. Okay. And this answer is the volume, or we can say it's 2144,66 to the nearest two decimal places. One of the two is perfect and is best for you. Okay, great. Moving forward to the next question. You see, this is nice, guys. Please don't leave question 9. When we are marking at the exam center, people always leave question 9 and question 10 sometimes when they're asked about maximizing and optimization. This is nice because we are just now applying the principles which you have already learned from the beginning, or from, what do we call this, from the first section of calculus. Now show that r squared is equal to 64 minus x squared. How can we show that? Oh, this is quite straightforward, because you can see that by Pythagoras we can solve that problem fast. So by Pythagoras theorem, we know that r squared plus x squared is equal to 8 squared. Okay, then r squared is equal to 8 squared minus x squared. Then r will be, we square both sides. Let's just do this here. So we square both sides, then r will be 64 minus x squared. So they told us, let's do this. Yes, so they told us show that r squared, so there's no need to square both sides. So our r squared will be 64 minus x squared. This was easy. We are just applying the Pythagoras theorem. Oh, I'm sorry, guys. Here we go. Yes. So by Pythagoras theorem, r squared plus x squared is equal to 8 squared. Then we make r squared the subject of the formula. There was no need for us to make r only the subject of the formula, because the question said that show that r squared is equal to 64 minus x squared. So we just did that. Then we get our 1 mark. Now let's look at 9.3, sorry. This is where the big issue or the big problem of this question comes, but let's break it down together. Determine the ratio between the largest volume of this cone and the volume of the sphere. Oh, so we are looking at the volume of the cone and the volume of the sphere. Of course, now let's just do this, guys. This is already easy. They've already given us the formulas. Now we just have to see there and look at the values. Let's do this step by step. Okay, so of course that should be, of course, the volume of the cone, which we're told that is 1 over 3 pi r squared times h. Of course, then let's go. This should be 1 over 3 pi. Then we have 64 minus x squared. Where is this coming from? We have solved it here on number 9.2 when they say that show that r squared is equal to 64 minus x squared. So we can apply the same principle there and apply it here. So where there's r squared, we put our 64 minus x squared. Then of course our height will be 8 plus x. You can see that there is x, there is 8 from O to what's this? Let's look at it deeply. So from O to B, that's x. Then from O to A, that's 8. So the whole perpendicular height will be AO plus OB. So you can see that, oh, this is quite nice and it's quite refreshing. Now, of course, we can solve this. This is the same as pi over 3. Then we solve these two. Now, can we solve that 64 times 8? That should be 512. 64 times x, that's positive 64x, and 6 negative x squared times that, that's negative 8x squared minus x cubed. Then after that, of course, this is the volume of the cone. But we know that we are looking at the application of calculus. Now let's look at dv over dx, okay, sort of like the derivative of the volume of the cone, because we want to calculate the ratio. Okay, so looking at this perspective, of course, this will be what? 64. Of course, this is a constant, and the derivative of a constant is 0. So the derivative of 64x, that will be 64 divided by 3, of course. So 64 pi 3. Then after that, you can proceed there. Then for x 8, negative 8x squared, that should be negative 16x. So divide by 3. So we also put that pi here. Yes, here we go. Then for this one, it's going to be negative 3 x squared, but we have that pi again, so we have negative 3 pi x squared divided by 3. Then after that, you can see, oh, okay. Then, of course, at maximum, or someone will say at largest, the derivative, which is v prime, let's just say this is v prime as well, is equal to 0. Of course, then we have now 64 pi over 3 minus 16 over 3 pi x minus 3. This is the same as actually pi x squared is equal to 0. Okay, then now divide and make everything to be nice. Then we have 0 is equal to 64 minus 16x minus 3x squared. Let's just put it back so that we don't get confused. They all have the same denominator there, so there was no need for us to cancel that fast early. Then equal to that. Then after that, you can solve for x, of course. 3x squared minus 16x plus 64 is equal to 0. Then we can solve for x, and we can solve this by looking for the factors, or you can use your quadratic formula. If you don't know how to use your quadratic formula, please do check our video on solving for x and for algebra. So this will be 3x and also x this side, so this will be 3x. Then we also have x. This should be x plus 8. Then for the 3x, this should be, let's say, 3x minus 8. Yes. Then equal to 0. Then, of course, you can see that 3x minus 8 is equal to 0, or x plus 8 is equal to 0. Then x will be 8 over 3, or x will be negative 8. Oh, definitely x can never be negative 8, because we are looking at the ratios. So definitely the x value which we are looking for is x equal to 8 over 3. But now this is now straightforward, because now we now know the volume of the cone, and also we know the volume of the sphere from the first question. So the volume of the cone will be 1 over 3 pi of 512 divided by 9 times 32 divided by 3, or divided by 2048 pi divided by 3. This denominator here, which we see here at the bottom, we can see that it's a value. Let's do this, which I've calculated in the first question here. Yes, here it is. Then now the volume of the cone is here. Then now we now know the value of x, which is 8 over 3. So we plug in 8 over 3 there. Then we end up having 512 over 9 minus 32 over, 512 over 9 times 32 over 3. Then we use our calculator. Then that should be 8 over 27, which is the same as 0.3, because that will be sort of like equal to 2 to the power 3 divided by 3 to the 3, which is 2 over 3 all cubed. Okay, then yeah, this is it. Then we can live happily ever after. Thank you so much, guys, for tuning in. This is what I was having for you in the morning, because this question is so important for optimization. Today at 1 o'clock, please look out for the full memo for June 2022, which was written last year. It has been there, it has been solved within an hour. So I want you guys to look at it and check it out. Without wasting much time, let's go through this again and have a great day ahead. Thank you. Oui.